This video is intended to give you some practice in order to help you improve your basic soldering skills while learning a little about electronics at the same time. If you have never done any soldering before, then ask your instructor for a few scrap electronic parts and try using them and your soldering iron to make up a few butterflies and animals like in these images before you make the circuit in this video. The first step is to mark the block of scrap wood or plastic with some lines that are the width of a typical school ruler. If the video is a little bit jerky, that's because we've increased the speed of the video so you won't get bored. If you are working with a block of wood, you can take some wood screws and push them a little bit into the wood and then screw them all the way in. In the junk box at the Robot Science Workshop, I found some old wire that can be used to make the positive and negative power rails to which we are going to solder the parts. Hold the wire in place over the nails or screws or bolts in the base onto which you're going to build your electronic heartbeat circuit. Now twist the wire around the heads of the screws or nails. It looks easy, but take your time and use the opportunity to learn how to handle the tools and the wire so as to get the best result. Now look at the diagram of how to lay out the physical circuit. Start with the light-emitting diodes and twist the wires around the positive power rail, which is indicated in the drawing with the red line. Once the long leads of the LEDs are twisted around the plus power rail, you can touch on where the two wires meet with a soldering iron. Please look out for our upcoming video on how to select a decent soldering iron that is capable of doing high quality electronics grade soldering at a reasonable price. Never do any soldering unless the tip of the iron is freshly wiped and is a gleaming silvery color. The flat spot on the body of the LED, which is also closer to the short leg, indicates the cathode. The cathode is orientated towards the negative side of the circuit, which in this instance is towards the bottom. You can use different values to the values we are showing here. Between 47 kiloohms and 220 kiloohms would give the best results. The electrolytic capacitors can also be changed to vary the flashing rate of the circuit. Here you will see we've already placed the 100 kiloohm resistors, and we're now placing the 1 kiloohm current limiting resistors that prevent the LEDs from drawing too much current and getting burnt out. Now we can take the NPN transistors and bend the leads into shape just like in the drawing. Almost any NPN transistor will work in this circuit, but here we are using a 2N3904. Do not bend the leads right up against the body of the part, as doing that can cause the leads to break off. Notice how in the drawing the face of the transistor is orientated upwards on the left, and the transistor on the right hand side, the face is facing downwards. In other words, the flat side is up on the transistor on the left, the rounded side is up on the transistor on the right. It is important to ensure that the circuit works, that the transistors are connected in this manner. If your circuit does not work once built, this is the first thing you should check for. If you look at the electrolytic capacitor, you will notice a stripe with minus markings down the one side. That is the negative side of the part. The short leg is also on the negative side. Take care to mount this part correctly, just like in the drawing. Wear safety goggles when handling electrolytic capacitors, as these can explode if connected in a circuit the wrong way round or to a higher voltage than what they are rated for. The value of the electrolytic capacitors used in the circuit is 10 microfarads, but you can also try using other values for faster and slower flashing rates. In this circuit, you should use electrolytic capacitors with a minimum rating of 16 volts or more for safety reasons, even if you run your circuit on a lower voltage. The last piece of the puzzle is to link the wires to the base of each transistor. We are going to use some insulated breadboard jumper wire here, but you can also use wire that is not insulated. Just take care that the wires do not touch where they cross over, just like in the drawing. Once the circuit is complete, you can add a battery clip like this to the circuit, which will make connecting power easy. Notice how we bend the ends of the power rails into loops to thread the power connector leads through, so they will last a little longer and won't simply bend a few times and break off. Notice how, if you've connected everything up right, the moment you attach power to the circuit, the LEDs will start flashing. This circuit will run on any voltage between 6 and 12 volts. To be safe, do not put higher voltages into this circuit, as the capacitors could explode and cause injury. Thank you for watching this video. Please subscribe to our YouTube channel and take a look at www.robotscience.co.za